Okay, in a th1 thread, I call th1.join. Background voice, if come, let it come. Why you worry about background voice? Think about my voice. Don't complain. Listen carefully. Let it come background voice. Any disturbance? th1.join. Then now tell me, when you call th1.join method, what happened? This thread execution is passed. Okay, this thread execution is passed for this thread execution complete. Then it's never completed. Enter to deadlock. Yes or no? The next. If I call in th2, if you call th2.join, I am telling to the join method, wait for th2 complete. The th2a thread is what? Same thread, na? So you passed waiting for yourself. You are waiting for yourself. So no one give an instruction to you to start. You have to give instruction to yourself. So in this case, tell me, th2.join when you call, will it work or will not work? Will not work. So it will lead to deadlock. So this is the first one. Second concept, this is the first situation where you will get a deadlock. Okay, th1.join and th2.join, this is a deadlock. Then second concept, try to understand. I am calling th2.join method here. I call th2.join. When you call th2.join here, now this th1 thread execution is passed, waiting for th2 complete. In th2 thread, I am calling th1.join. Below now, th1 is waiting for th2 to complete. th2 is waiting for th1 to complete. Both never complete because both are interdependent. Both are waiting for each other. It's never complete. Hope all you understand. Okay, na? The program is never terminate. So it is become what? Deadlock. Then next. Third situation is because of synchronized keyword. It is calling synchronized method. Okay. th1 is calling synchronized method. th2 is also calling synchronized method. Okay. Both synchronized methods are called by using same object. Both synchronized methods are called by using same object. Then tell me, until th1 execution completed with the synchronized method, th2 thread has a chance to execute? No. Until th2 thread execution not completed, th2 thread execution not completed, th1 thread doesn't have a chance to execute. Both are interdependent. Are you catching my point? Now I will show you. Yeah, join method wise locking is not a program, not required. So now I'm trying to explain with a synchronized keyword wise flow. Listen carefully. I'm taking two objects. I'm taking two objects. First object method name is M1 and second method is M2. This is first class object. First class object, M1, M2, two methods are there. Both methods are synchronized methods. M1 is also synchronized, M2 is also synchronized. Next we have second class, another class name is second class. It has the object, second class object also created. It also contain two synchronized methods. Synchronized M1, synchronized M2. Or you can say M3, M4. Okay now? Now, first thread I created, two threads I created. Inside first thread, by using first class object, I call M1 method by passing second class object. Okay now? M1 method have the parameter second class. And M3 method has a parameter first class. Now all you people answer. When you call fc.m1 of sc, m1 method get access to this first class object, and also inside m1 method it got access to second class object. Yes or no? Now my question, because of fc.m1 of sc, which object is locked? Second class object or first class object? Am everyone to answer? First class or second class? Second class object is locked. Which object is locked? Second class object is locked. Second class or first class? Current object is locked. Na? Current object is locked. Argument object is not locked. Then, now M1 method execution started. Inside M1 method execution, object is passed. Thread execution is passed. When thread execution is passed, control will come to second thread. Here, second thread dot M3 of by passing FC. All the people answer. When an object is locked, can I pass that object as argument to another method? Yes. We can pass as an argument to another method, not a problem. When an object is locked, what you cannot do? You cannot call synchronized method by using that locked object. But we can pass it as an argument to another method, not a problem. Okay. Then when you pass second object here, what happened? Tell me. Second object is second thread got access. M3 method get access to second object, and because M3 is synchronized, the second object is locked. Okay. Now from the second synchronized method, M3 method pointing to first object. Hello, all people understand? Then this thread execution also paused. This thread execution, M3 method execution also paused. I call thread.sleep. Now JVM shifting to first method. In first method, by using second class object, I am trying to call M4 method. Is it possible? Is it possible? From here, M1 method using second class object, I am trying to call M4 method. Is it possible? Not possible, because to call M4 method, second object must be locked by current thread. Current thread must obtain the lock of second object. Okay, na? So its execution is paused. Then JVM shifting to M3 method. Inside M3 method, after pause time, I am calling first class object dot M2 method. Tell me, is it executed or not executed? Not executed, because first object must, second thread must obtain the lock of first object. Okay, and then now already first class object locked by first thread, second class object locked by second thread. Both threads execution is paused. Okay, how long? Until first thread release the lock on first class object, second thread release the lock on second class object. They never ever released. Both are interdependent. Both are internally depending on each other. They never terminate. Then threads execution will go for deadlock situation. Observe the program here I have developed. In your material also there same program. first class method with the first method with the second class object parameter. And then I call sleep method. When I call sleep method, then control will go to second class, second method. Then here this logic executed, it is also paused. Then control come to first class method. In first class method, we are calling sc dot last method. Paused here. Yeah, then control is coming here. Here is calling what? First class last method. Paused here. Finally, threads will enter it into deadlock situation. So if you use synchronized keyword wrongly, if you use synchronized keyword wrongly, program entered into deadlock. Look at that. First class object is locked by thread 0. First class first method is start. First class method pass. Second class object is locked by thread hyphen 1. Second class second method start. Second method is passed. First method is resumed. Okay. Sc dot last is about to call by thread 1. Sm is passed. Second method is resumed. First class last method is about to call thread 1. So both are locked. Both are passed. Got clarity? All you people understand? Okay, this program there in your material, practice it by writing diagram, you will get clarity. Just to follow the flow of execution. If two threads are depending on each other, then deadlock will come. Okay, make sure that deadlock should not be there. You must use a synchronized keyword effect, carefully. Okay, you have to call this last method only after, we have to call this last method only after first class object is released. Before releasing itself, we call deadlock will come. You have to make sure synchronize the method calling properly. Okay, if you not understand, don't worry. Okay, leave it and try to practice one more time. You will practice because there is a flow of execution. If you are good at flow of execution, then only you will understand. So daily, if you are practicing, it will be easy. If you are not practicing daily, it creates problem. Fine. So now today we are going to the next topic, inter-thread communication topic. Okay, na? Very easy topic, very simple topic. Inter-thread communication. Last topic in multi-threading chapter. Okay, now let's understand what is inter-thread communication. The process of executing two threads sequentially and alternatively with communication is called inter-thread communication. Now try to understand. I have one thread object. I have one class object. Two threads are accessing. Two threads are accessing the same object. Can you please check? Are you able to hear me? All the people able to hear me? Huh. Now try to understand now. I have two threads now. First thread is accessing this object for modifying this object data. Second thread also accessing this object for modifying this object data. Then we should not allow both threads to execute concurrently to modify that thread. We should execute sequentially. For that, we apply synchronized keyword to the method modify and allow both the threads to execute this object, this logic sequentially. This is the first scenario, VLAN synchronization. Synchronization, second scenario is also there. Okay, na? Synchronization, second scenario also there. What is the synchronization second scenario? Synchronization second scenario. I have an object. We have two threads are there. First thread is trying to modify this object data. Second thread is trying to read that modified data. Second thread is trying to read that modified data. Tell me, synchronization is required or not required here? Tell me now. Synchronization required or not required? Required. Because while modifying object data, we cannot read. While reading data, we cannot modify. Both must execute sequential. Point number one, we should use synchronized keyword. Both modify method and read method, both I must declare it as synchronized. Point number one. All you understand? Next. Point number two, when this read operation can read data, when this read operation must read data, when you must read this data after modifying. That means this read method execution should pass until modification completed. After modification completed, only read method should execute. That means if you take just a synchronized keyword, can you stop read method execution until modify operation completed? Is my question understand? Using just a synchronized keyword, can you pass, can you communicate to read method? Are please wait, modify method not completed its execution, please wait. Can I say? No, I cannot. Next, using just a synchronized keyword, can I inform to read method, okay, my writing operation completed, you please read? No, right? We have to use, in addition to synchronized keyword, I must also use two more methods, wait method and notify method. Wait method for passing the thread execution and notify method for notifying this thread to resume its execution. So if you want to develop inter-thread communication, we need to use how many operations? 3. Synchronized keyword, wait method and notify method. Okay, na? Synchronized keyword, wait method and notify method. 3 things I have. The code to understand this. Next question. How many times I am going to modify? 1 to 10 times I want to modify. 1 to 10 times. How many times I should read now? 1 to 10 times. As many times read, as many times write, those many times I should read. Now 1 to 10 times you must read and modify in what fashion? First modify, then read. Then modify, then read. Then modify, then read. Then modify, then read. Yes or no? Modify and read, you should execute alternatively. Then go back and read the definition. The process of executing two threads sequentially and alternatively. What the meaning of sequentially? While modify method executing, read method should not execute. While read method executing, modify method should not execute. Everyone understand that? While modify executing, read should not execute. When read executing, modify should not execute. That is sequential. And read method must execute only after modify. Modify should execute second time only after read. Read should execute second time only after modify. That is called alternative communication. So for this purpose, you must use the help of wait and notify. Okay. Then can you give me real life examples where this threads alternative execution is required? Okay, you can take factory operations. Factory should produce items. Factory, if you take factory should produce. Factory should produce items when first factory should produce items and consumer should consume items. This is the story of the factory example. Now tell me, factory can produce items only when order is coming now. Producer should not keep on produce the items. If he keep on producing items, then what happened? Loss will come, right? If the producer keep on producing items, he will get loss. Yes or no? Consumer should consume items when only after produce. That means producer produced item, then he has to wait until consumer consuming item, then produce, then consume, then produce, can consume. Yes or no? Next, I want to take hotel, tiffin hotel, okay? Tiffin hotel. Tell me, in a tiffin hotel, you can see, right, roadside tiffin bandi will be there. On that one plate will be there. In that plate, puri will be there. Puri or samosa. Tell me, this tiffin hotel owner must manufacture the puri, first one, some around 10 items of puri as manufactured and placed inside on a plate. Then when he has to manufacture next 10 items of puri after customer eat, na, then next again puri, next Telugu we call it as a wire. Next wire puri will come after eating. Again customer should come eat. So without eating, if puri manufactured, puri prepared, loss will come, na? So if you take a business, in the business you must follow produce, consume, produce, consume. While producing, consumer cannot come to consume. Consumer cannot come to consume. Yes or no? While preparing the puri, in the middle of the puri, customer cannot eat. So if in the middle of the puri, customer eating, you know that oil, hot oil will go into his mouth, his entire body will burn. So this is the concept. Now I want you understand implementation. Are you ready? I want to develop factory example. Class factory. First of all you people got clarity on concept? Private int items. Private int items. Private string, not required anything. I wanted to know whether these items produced or not. Private boolean items available. Okay, generally item only will be there. Singular will be there. Public boolean items available. Now this factory should have two operations. What are the two operations? Produce, consume. Tell me, this is synchronized keyword, this notify method, all these things we have to use in synchronized keyword, wait method, notify method, all are available in thread class, thread implementation class, object implementation class. Come on. We should apply synchronized keyword to business operation. While business operation is performing, I want to pass execution. So wait method also I must use, notify method also I must use in business operation method. Okay, right. Here I am writing produce method. Public void produce of int item. How many items you want to produce? That a number of items I am ready to produce. This dot item equal to item. Next, public void consume of. How many items you produce, those many items should consume, na? Item. And then next term, what do you write? This dot item equal to this dot item minus item. Here this dot item plus item. Okay, now got clarity? Yeah? Now, in order to call these produce and consume methods, I need two people. One producer person, one consumer person, right? So I'm creating threads. Class producer. It is a project, so I want to use implements runnable, and then override at the rate override public void run open bracket closed bracket. What this run method has to do, we should create factory object dot produce of how many items to produce, I number of items. That means I should call produce method in loop. I want produce 1 to 10 times na 1 to 10. So what I need to write for loop, for open bracket closed bracket int I equal to 0, I can say 1, I less than or equals to 10, I plus plus I number of producing. Now tell me, if you want to produce, I need factory object. Producer doesn't have his own factory, he will join in one factory na. So I should take private factory comma, and to initialize the factory object public factory of public producer of factory. This dot factory equal to factory. Okay, is it clear? The next class consumer implements runnable. Next, tell me, same code na? Same code, right? What is the difference? Factory in place of produce, I am calling consume. Produce plus consume of I. And then now I am writing main method class test 30 underscore ITC factory Bajaj company factory I am taking. Now I am creating producer object prod equal to or producer equal to new producer of Bajaj. Consumer equal to new consumer of then thread th1. I need to start threads now. New thread of. Now this thread should execute with producer. Second thread th2 executed with consumer. th1 dot start, th2 dot start. Understand what I have written code? Try to understand what the code I have written. One object class, two thread classes we have developed, and main method class to start those two threads. Now tell me, producer is calling produce method, consumer is calling consume method. Both produce logic, consume logic should execute concurrently or sequentially. But is executed sequentially or concurrently? because there is no synchronized keyword. So I should correct that mistakes. So I am declaring this method as synchronized. Okay, 1 minute. Let me first continue this program. System dot out dot println of double quotes items produced plus I. Items consumed plus I. Save it. Control 1. Look at that, how this is coming. Why coming? Items produced -3, items consumed -3, items consumed -4. Items produced 0, items produced -5. Look at that. Are you getting proper code? Look at that. Without producing, 0 items consumed, -2 consumed, 0 produced, -3, -5, -4. Is it a right design? Wrong design. I have to synchronize them. Should not execute zigzag way. I should synchronize them. Should synchronize? No need to do any change in the threads. We have to control from where? Here. Synchronized. And same consume method also should declare as synchronized. Okay, I synchronized. Items produced 1, consumed 0, items consumed -2, items consumed -5, items consumed -9. Why it is coming minus? Okay, items consumed. Look at it. Without producing, items consumed. Wonderful, na? Without producing, item consumed. Okay, item produced, 10 items produced. Then now the consuming is going on. Is it right approach or wrong approach code? Wrong approach code. So it's the time we have to develop. What concept we have developed? Only synchronization we develop. Only we develop synchronization. But I want what? Alternative flow of execution. First produce, then consume, then produce, like that. For that purpose, this logic should execute. Items produced only when there is no items. Okay, if items available, I should write communication now. If items available in the factory, should I consumer? I should wait. I should pass currently running thread. Are you catching my point? I should pass currently running thread. To pass the currently running thread, I have 3 ways. Number 1, thread dot sleep off. Array, now this thread should pass independent of other threads or depending on other threads. Depending on other thread, right? Until other thread consuming, it has to pass. So sleep method suitable or not suitable? Not suitable. The next, I have to use what? Join method. Okay, now that consumer thread dot join method I should call. Okay, if we call join method here, control will go to consumer. In a consumer also I should call join method on produce dot join method. Hello, if we call join method on 2 threads each other, it leads to what? It leads to what? Deadlock, right? Two threads if mutually calling join method leads to deadlock. And moreover, another problem is there. Also, this consume method never executed. This consume method never have a chance to execute. Why? This consume method never get a chance to execute. Why? Okay, when you call consume.join method, this method execution passed here. If you want to execute consumer thread, factory object lock should be available now. Come on. When producer call produce method, factory object is locked because produce method is what? Synchronized method. Factory object is locked. When passed its execution, factory object is unlocked or not unlocked? Not unlocked. Then if are not unlocked, control will go to consume method or cannot go? Cannot go. Then join method is not suitable here also. Join method is not suitable. Thread is sleep method is not suitable. Join method also not suitable. We need one method to perform two operation. First operation, release lock on current object. Release lock on current object. Release lock on current object. Second, bolo. After that, pass currently running thread. Pass currently running thread. Release lock on current object, pass current thread. Two operations has to perform. That two operation performing method is wait method. What is the method? Wait method. Sun Microsystem has given one predefined method called wait. Now the question, this wait method available in thread class or in java.lang.object class? This wait method is available in java.lang.object class. It is not available in thread class. Why? This wait method should call on current object. Na? You want to release the lock of current object. So which object lock you want to release? That object dot you have to call. And then inside wait method, by using thread dot current thread dot, by using thread dot current thread method, it can obtain the lock of the currently running object. Na? So wait method is available in java.lang.object class to call this method on current object. But wait method passing the currently running thread execution, it will throw interrupted exception. We must handle this exception. Okay, try, and then following by what? Catch of interrupted exception E. Okay, got clarity? So you should call this dot wait method inside thread, inside a try block. Now tell me, if you call if items available, then what happened? Program execution is passed. When? First time or second time? First control is coming into produce method. Produce method call items available. False. Then go inside items produced, displayed. Then for loop, produce method call again. Control coming. Hey, items value I should change here na. After production completed, I should change item available equal to true. Item available equal to true. Then control will come in the loop. Item available true? Yes, pass. When you pass, then control will go to what? Consume thread. Consume thread. Also here also we should write if condition. When it should consume, not immediately. It should consume only if no items available, it should pass. Hello? Already catching my point? If no items available, then you have to pass the thread execution. You should call wait on the same factory object, this dot wait. Easy point only. Just you need to remember the theory and apply the theory here. Interrupted exception E. Then this dot items equal this dot items minus items, and then I have to write here what? Items available equals to false. Look at the program compiled. With this modified code, can you guess what is the output of this program? What the flow of execution? With this modified code, what is the flow of execution? My guess is this program entered into deadlock. Why? All people think and tell me. My guess is this program is entered into deadlock. Anyone can guess why this program entered into deadlock? All people got clarity? This program will be entered into deadlock. One item produced, one item consumed. Okay. Why? Why? Because did you inform to consumer you produce item, after producing item you re-executed and entered into wait state. Did you inform to consumer to consume? At end of the method you should call notify. Then consumer will resume. Consumer will consume item, again deadlock will come. Items produced one, items consumed one, both are in waiting state. Why? Producer not resumed because consumer not notified. So you have to notify, for that you have to write last. So wait method meant for passing the thread execution, notify method meant for notifying to other thread. Now program executed successfully. Compile and execute. Look at there. Items consumed, items produced. Sequentially, alternatively, sequentially, alternatively, sequentially, alternatively. Everyone understand? Please open material. In material, the same program is available with a complete explanation. Please verify. Spend 5 minutes time. Can you tell me, can you implement same project for deposit withdrawal operations? Can you implement same project for deposit withdrawal operations? Can you try yourself? On a same account, I want to deposit withdraw. First deposit, then withdraw. Deposit, withdraw, deposit, withdraw. So this is the final program you have to understand with what you call multi-threading chapter. So in multi-threading chapter, from the interview point of view, people will ask three questions. One is, what is custom thread? How many ways we can create custom thread? Okay, which is the best approach? We can create custom thread in three ways by using we can create custom thread in three ways. Number one, by using extend from thread class, by using implementing runnable interface. Number three, by using implementing callable interface by using executor framework. Okay, implementing callable interface, executor framework, all the concepts I will teach you next Sunday. Actually, we plan to have the class this Sunday. 7 a.m. batch not yet completed. So this Sunday, I'm not taking class for you. I'll take class next Sunday. Okay, na? 7 a.m. batch pending topics are there. I need to complete. So I'm taking class next Sunday. This Sunday, no class. Multi-threading topics I'll take next Sunday. Is it clear to all? Have you heard? Next. Second question they will ask, thread life cycle states and execution algorithms. Third, they will ask types of threads. Fourth, they will ask synchronization. And fifth, they will ask inter-thread communication. These are the common asking questions in the interview from multi-threading chapter. I covered complete syllabus. And these are the common topics. Okay, now the pending topics you need to learn are thread local, okay, and thread local, thread group, and what do you call executor framework. Okay, so these are the three topics are pending. These are three topics and ninth topic, locks. Okay, re-entrant locks. Okay, re-entrant locks. So these are the things we need to follow. So these four topics are pending. I will cover next Sunday. Okay, and next tomorrow I cannot take class for your batch. No class tomorrow. Next class is on Monday. We will start collections. Is it clear to all? By Monday you are coming. Can you finish string handling, all string handling chapter fully? By Monday you are coming. Can you complete string handling chapter fully? Tomorrow, day after tomorrow, please spend time on string handling chapter and complete fully. Thank you. That's all for today class, and we'll see you on Monday. Tomorrow no class for your batch. Can someone answer to him? Choose everyone. Choose everyone. And can you please someone answer to him? Maybe he wake up just now. Choose everyone and answer. Reply to it. Choose everyone. Choose everyone. Then only he can see your answer. Thank you all. See you on Monday. Monday will start collections. Tomorrow, day after tomorrow, 2 classes. 2 days no class. Next class is on Monday. Monday will start collections. Now complete string handling chapter and come. Okay. Thank you. Bye bye.